afternoon, everyone. My name is Kim Lockett. I'm VP of Marketing here at Knowi. Thanks for taking the time today to join our Q1 product update. I have with me the lovely Lorraine Williams, our head of customer success, and she'll be running through a few of the highlights and doing a quick demo of the major enhancements we've made over the last few weeks. Before I hand it over to her, though, a couple of housekeeping items. First, you guys are all on mute, but we do want it to be an interactive session. So please make use of the Q&A section that you'll see on the bottom of your control panel in the Zoom webinar control panel. You can just type in your question there. We'll see it, and if we don't get to it during the session, we'll get to it at the end and make sure we can answer all of your questions. We'll also be recording the session, so we'll be sending it out after we're done. You'll probably get it either later today or tomorrow morning. And with that, I'm going to hand it over to Lorraine to get us going.
Okay, thanks, Kim. Good morning, good afternoon, everyone, and welcome to the Q1 Knowi product update. I'm going to touch on some of the main features that have gone into the product over the last few months. But again, before I get into specifics, I just want to remind you all that full documentation and release notes can be found at docs.knowi.com. All docs are searchable, so typing in a keyword or phrase usually gets you to the right spot. So for example, if I type in machine learning, which will be a topic for today, then that should take you to some of the results from machine learning. You may have also noticed that where our docs area has undergone a little bit of an overhaul. So release notes can now be found under what's new. And this basically also leads us on to a new feature that we have, which is our community forum. So this will allow you to post, and for the Knowi experts out there, and I know there are some, to also answer questions for your fellow Knowi user. So obviously content is key for this, and it is early days. But we are entering tidbits all the time, and we welcome posts from you as well to help kickstart the process. And obviously, if all else fails, then sending an email to support@knowi.com where we'll get our attention, and then we'll do what we can to assist you as soon as we possibly can. So I'm going to head back over to our main site. If you're not currently a Knowi user, or you haven't even tried to try the system out, then I would suggest signing up for a free trial. It's 14 days and you get access to the whole functionality to take it for a test drive. That's really, really handy. And again, if you need any help with that, then support@knowi.com is the place to go. I'm going to actually go and sign into my training account here. And pull up just the basic dashboard that I got here to show you some examples of certain things. So the main feature that was incorporated into Knowi in Q1 of this year was our machine learning data preparation feature. As it's obviously important to ensure that your data is ready for the downstream algorithms that to successfully run against. So I'm going to hop into the machine learning module that's down here. And the very first thing you do with machine learning is you create your workspace. So a workspace can just be thought of as a big folder that contains all your models. When you typically do machine learning, you will run many, many models on your data set, on your training data set. You will choose different features. You'll choose to maybe create dummy variables sometimes, or to normalize or standardize sometimes, widen your data set, whatever you want to do. So you would run models many, many times, or run algorithms many, many times on your training data set, and end up with a whole bunch of different models. And so a workspace is really just a giant bucket that you can put your models for that certain use case into. So I'm going to create a workspace, and it's going to be the credit card example, which is classification. So I'm just going to go Q1 there. So right now we support two types of machine learning algorithms: classification So if you need to actually predict what a category or bucket something falls into, so for example, in this case for our credit card, it would be, will the customer pay next month or will they not pay next month based upon their prior payment history. Or regression, which is basically trying to predict a real numbered value. For example, what will my sale, based on my previous sales history in this certain area of the country, what are my predicted sales figures going to be in 2026 or something like that. I'm going to just do classification just to show you the example here. So the very first thing you want to do is you want to select your training data set. Obviously the training data set is something that is historical. It already has the attribute you're trying to predict in it with what the real value that it turned out to be. So I'm going to search for training and pull up my training data set there. I could actually upload a data set right there and then if I wished. The next thing I want to do is to be able to select what I'm trying to predict. So these are all the features in my training data set, the sex, education, marriage and age of the customer, the credit card customer, and then the billable amounts and whether they paid or not. So I actually want to say, okay, I want to predict whether or not they're going to pay. And then the next thing I do is I'm going to look at my data. Always very, very important to look at your data. So this allows me to go and see it. It's already telling me what my prediction candidate is, how many columns I have, how many rows in my data, for example. And then I can basically also select on these little icons here, and it can give me some statistical distribution data analysis. Is this a Gaussian distribution or is it not a Gaussian? Obviously, in this case, it's not Gaussian. And these type of things can help you downstream pick your algorithms. Some algorithms like Gaussian distributions more than others, and this sort of thing. It also gives you obviously what type it is, and whether there are any missing values for this data, how many distinct, and what the mean and standard deviation are. And that happens on every column. So you can get some sort of idea of what data you're dealing with here. You also have the option here to do any Cloud9 QL. If you're already a Knowi user, you'll be very familiar with our Cloud9 QL. It's our own language that allows you to transform your data. And if you needed to do any transformation, you could do that here. I'm not going to do that, and I'm going to go on to our new step, which is the preparation. So the very first thing it's asking me to do is just check my data types. Are these what I'm expecting as the data types for each of my columns? I'm going to just click on yes and go through to the next step there. Okay, hang on 1 second. My Wi-Fi is a bit slow here, I apologize. And obviously, checking data types is really important for when you're running through certain algorithms, because some things will actually want things to be integer and not string. So it's very important that happens. Hang on a sec. Okay, let me just try again. Oh, okay, sorry about that. Let me go into my workspace. No. Okay, so the next thing I want to do after sorry, my Wi-Fi went bananas there. So the next thing I'm looking at after checking that my data types are of the right type is it's now going to highlight any outliers that I might have in my data. If I have outliers, it will highlight them, and it will allow me to, if I wish to, it'll allow me to remove them from the data set. I can also skip this step as well. None of these steps, or not all of these steps are mandatory. Again, we're leaving it up to you to make the decision. All we're trying to do is highlight certain things. So I'm going to go to the next step here, which is missing values. So obviously, we don't want any missing values. That provides zero information for your model. So if there are missing values, you would probably want to remove those, or you might want to impute them and impute from the mean of the distribution. I don't actually have any missing values in my data set. If I did have some missing values, it would have highlighted them for me and given me two options. Either just remove this row, or if a whole column is missing, then it would give me the option to remove that column, because there's no information gained to be had there at all. Or it could say, if there's not too many missing, then you might want to impute from the mean of that distribution for that particular column. Again, I don't have any missing values on my data set, but if I did, they were the options that I would have there. The next thing, and again, this again is optional, is to possibly rescale my data. So for some numeric data, for example here, I have, some of it could be of different scales. So I might have weight, age, and height. They're all numeric, but they're of different scales. And rescaling sometimes does help downstream algorithms cope with or perform better. Again, it's not necessary, but it might be something that you might want to try. And so what we give you the option of 2 different types of rescaling methods: normalization, which allows you to basically well, basically you do this if you don't know the distribution of your data, or if the distribution is not Gaussian or not a bell curve, and this will set all values across the board between 0 and 1. Again, you don't have to do it. And then the other one is standardization, and this is handy if your distribution of your columns, or the columns that you select here, are Gaussian, and it will standardize with a mean of 0 and a standard deviation of 1. So again, optional though, you don't have to do it. What I would typically do is I would run it with not doing it, and then I would create another model with normalization, and I would create another model with standardization, and I would see how those models, what the percentage accuracy rates are of those models. Hence, that's why I say the workspace is really good, because you would end up with a bunch of models that you want to compare against. I'm going to just go to the next step. I'm not going to bother with that. Discrete groupings is, again, another optional step. And so some algorithms, like decision trees, work better with discrete data. So this means taking numerical data and converting it into logical ordered groups, or bins. It's pretty useful if, for example, you believe there are natural groupings within your column data, or, for example, if your numerical data, has a really large range of values, like you're going from -infinity to 7 billion or something ridiculous like that. You probably want to bin that a little bit and create discrete groupings. So this really just allows you, if you wish to do that. Again, you don't have to, but it could help with performance of downstream algorithms if you do. And you might want to try not doing it and try doing it. Dummy variables, I don't have any dummy variable candidates here, but some algorithms only work with numerical data. So if you have a string, for example, you might have a column which is gender, and in it you might have male, female, and unknown as strings. That's going to be wasted on that column is going to be wasted basically on some algorithms if it's expected numerical. So what you would do is you would widen your data set and take that one column called gender, and you would widen it to have 3 columns of male, female, and whatever I said, unknown. And then you'd, for example, if you didn't know the sex, it would be 0, 0, 1. So 0 in male, 0 in female, 1 in unknown. So you're just widening your data set and making it numerical. Again, having a wide data set is typically suggested, but again, you don't have to. Pretty much this is, these are the new steps we put into our data prep for machine learning. They're very, very handy. And again, I would suggest you try different permutations and combinations of that when you're running your models. The next thing is features. Oh, by the way, before I move on to features, everything that you did there would be stored. So if you had to come in and come out, like when my Wi-Fi went bananas just now, when I went back in, it knew the next step I was going to go to. So it saves every step along the way. The next thing I need to do is now select my features. Now my data is nice and clean. So basically, on selecting features, you have a couple of options. It's going to list all the features within my data set, and it's going to allow me to either manually select the features that I wish to run my model against. And again, I would run many, many different models, selecting many different combinations and permutations of features. If you have obviously subject matter expertise and you know that a couple of things are collinear, you'd probably not want to select 2 collinear things at the same time. But again, that's the whole idea of machine learning, is that you take your time in running these multiple models with different selections of features. So I could select, or I don't particularly want the ID values there. They're of no use to me at all. And I could have removed these, by the way, in Cloud9, and I forgot. Or I could have the system auto-select some features for me based upon algorithms that it runs to try and get some information gain of pitting one feature against another and seeing how they relate. Again, I would do all of it. I would use selection to kickstart me, and then I would go in and then I would do different permutations, combinations of the manual features. So I'm going to just go and select on that. So the next thing is, I'm doing classification. So right now we support 4 models, algorithms actually, 4 algorithms. And we're going to be bringing more and more in over time. But right now we have 4. We have 4 pretty common ones for classification. I'm going to select all of them. I am going to go into K nearest neighbor, and having a neighbor of 1 isn't very good. I'm going to put 3. But you can go in and change the settings on all of these models. And again, every time you run them, you might want to change, whether it's Euclidean distance or a different type of distance measure. That's why machine learning typically takes a long time for your data science department to do, because there's always lots and lots of things that you can try. And the next thing I'm doing is going to train my model. And what it's going to do is it's going to take my training data, all the prep that I did, the features that I selected, the little settings I did for my K nearest neighbor, and what it's doing is it's running them through all of these 4 different algorithms, and it's coming up with some results. So I can see that logistic regression looks like it did pretty well. Decision tree did pretty well too. You can click on here and you can actually see the data. So it's given me an indication of what the predicted data looks like. I can also click on here, and it's going to expand and give me some accuracy and some statistical information that you can compare against, for example, decision tree. But it's also going to let me know what data prep decisions I made along the way, so that I can always remember, oh, okay, yes, I had, I didn't do any C9 QL, but and I had all of these type of features, and I didn't have any missing that things, or I rescaled or whatever, so that you always have an idea of what you did if you want to rerun this one again, but for example do normalization the next time through. So once I have done that, you'll see down in the history, it will log basically every time you run, the run date and time, and then all the models that you actually created and what their basic information is. So again, I could run this many times with different models, and then basically then decide over a period of time which one I think is going to be applicable and useful for my ongoing data for prediction purposes. So I'm going to just select this one to say, okay, this one looks great. I'm going to publish it. So I give it a name. So I'm going to call it a Q1 model. Very original there. And I'm going to publish that. And when I publish it, you'll see that basically this one now is highlighted as being pretty much published. Now, I'm not using the model yet. I've just published it. It's available to be used against data, real data coming in. So let's give that a go. So I'm going to pretty much go into use model, and it's going to take me to my query page, because obviously I'm going to use this model against data coming in, fresh data that doesn't have that default. Did they pay or not? We don't know. This is data coming in on as the people are using credit cards, for example. So I'm going to go in here and I'm going to select Mongo. This is where my data is coming in from. And I think it might be called default credit card. And what I'm going to do now is I'm going to say I want to apply my model to my credit card, my live credit card information coming in from my Mongo database. And it's going to ask me, well, what model? And I say, well, I've spent lots of time on this, and I've decided that my Q1 model is the best one to do. And basically that's as simple as that. This is how I associate it. So you can see this is all my data coming in. This is my fresh data coming in. But you should be able to see at the end, this one here, it's the predictive, will they default or not? And you have some will and some won't. So what I can do here is, say for example, this was the customer ID. I could have the customer ID there, and then I could also then basically just to highlight the predicted value that I just predicted using my, I can't remember, it was logistic regression, I think. And then I can basically say, I could say basically, I want to basically see when my predicted equals 1, and these are all the naughty people that probably won't pay their bills next month. And then I can also hook that into our alerts function, which allows us to then create trigger notifications that will monitor this data set and then alert me real time on whether or not, for example, in this case, my customers will maybe not pay. And I can send an email, I can call an API into, for example, the finance system to say, hey, here are the candidates we need to keep an eye on. We think they might not pay this month, or we can Slack to a channel. So in a nutshell, that's what we've been doing on machine learning. It's actually pretty good. And we would love you all to really give it an outing in earnest. We're pretty proud of it, and yeah, and it's growing all the time. More algorithms are coming, and also just to let you know, hopefully in the next quarterly update, we will also have a third box here, which will be time series anomaly detection, which is unsupervised learning, where we basically analyze your time series data as it's coming in and then alert you to any anomalies in that data. So keep them peeled for that one that's going to be coming shortly. So as you can tell, machine learning was one of our larger areas that we focused on over the last few months. However, we've also added some other neat features too. So first, let me nip over to our query management and show you what else we've been busy with. So I go into my list of queries, and I'm just going to pull up this query here. Oh, before I do that, I just want to remind everyone, and especially the people that haven't yet, aren't Knowi customers yet, or maybe haven't selected or signed up for an evaluation. We do natively connect to over 30 different types of data source. This is really what sets us apart from our competition. We do it really, really easily and very well, and we allow you to blend across all of these different types of data sources, including REST APIs, to formulate and to get a holistic view of your data from which you can do downstream visualizations. So when you've done all of that and you've potentially blended across certain types of data source, then you end up with what we call a query. If I pull this one up, this is just a very basic query that combines Mongo with MySQL, and to get basically Mongo is here and MySQL is here, but this whole data source here is basically what your downstream visualizations and analysis and machine learning potentially will be based upon, and we can run them real time, or we can cache these results on the schedule asynchronously. So one of the things we put in is the ability to cancel. So for example, if you were doing a query, and when we create queries, we run the queries, we push the queries down to your own data sources, we leverage the power of your own machines. Basically, we have the ability now to be able to cancel a query. So as you know, we don't copy and move your data as in the traditional ETL model, but we act upon the results brought back from a Knowi initiated query. The behavior of the cancel action depends upon the data source type and may not result in the ability to actually kill the query on your end. However, the thread that's executing the query from our side will be interrupted, and it thereby allows you to disconnect and do something else and do a new query. So basically, cancel is actually quite a good thing that we put in there. Another thing that we've done, if I go into, I'm going to go to a new query. I'm going to show you something we've done on the Data Explorer. So I'm going to think it's Mongo. I'm going to create a new query using my Mongo. The Data Explorer down here, some people actually don't know this is here, and it's really handy. If you click on it, I've obviously connected to my Mongo. You'll see all the collections within your Mongo, or if you're Elasticsearch, it would show you all your indexes in Elasticsearch, whatever. But this allows you to, if I select, I think it's on the sports, where is it? Sports, or is it Gamebook, I think. So this allows you to click on a collection, and then from in here you can see that the sports statistics is nested. If I click on that, Gamebook is nested. If I click on that, defense statistics is nested. And basically what I'm trying to get at here is we allow you to, or we sample data. I think it might be the first 10,000 documents, I'm not sure. But we sample the data at a nested level to really allow you to be able to then drag and drop those things into your metrics immediately. So this is something that we've enhanced. We didn't go to that level before. Now we actually allowing you to go pretty deep with your nested arrays. if you have them, especially in your NoSQL data sources. I'm going to nip back over to my data sources page, and on the REST API side of things, we have, I don't have anything interesting to show you here physically, but basically I can talk to it. We've added an array index pagination. We've added just a new type of pagination. So index array pagination allows the first call to return a JSON containing the fields along with the total page count. So number of pages to page through on the pagination to load. And then we are able to load all the pages using separate JSON post payload, passing the page number into it, and then which is run in subsequent requests, iterating over those page numbers. So if you want full details on how to configure that, you know how to do it. I've just trained you. You go to docs.knowi.com, and then basically in here you can just type in, if I can spell it right, REST API, and hopefully you should be able to get the information on our new, I think it's at the bottom, our new array index pagination, and we also give you some ideas of how to configure that. On the visualization type side of things, we've added a pivot table visualization. So this supports the easy pivoting of data without the need for Cloud9 QL. Before, you had to use the Cloud9 QL transpose function, which is also fantastic, but now you don't have to use that if you don't want to. So I'm going to just basically go and show you an example of that. I'm going to go in, and I think I've got, I'm going to drag this widget onto here. I'm going to add it in. So right now it's a grid, but what I want to do is I want to make it a pivot. So I'm going to go, the pivot table is next to our grid, and it's in beta right now. We are adding in new things to pivot all the time. So I'm going to click on the pivot. Now, generally, I can change the color and the font size, and I can fit the pivot to the width, sorry, of the widgets. That's really hard to say, using the basic settings here. But if I want to configure the data side of the pivot table, then I click on configure here, and then it just gives me a list of all my tabulated data. So what I want to do is I probably want, as rows, I probably want my customers. And then as columns, I probably want to know what type of email they were sending. The value, probably how many were sent. And then on the filters, yeah, probably by customer. I probably want to filter by customer. So literally you just drag and drop these things over, and I'm going to apply that, and I'm going to save it and go back to my dashboard. And hopefully, did I not save it? Let me see here. Oh, I didn't save it. Okay, sorry about that. Customer, message, sent, and then filters. Okay, well, we can see it here. So basically what we can see here is my customers are on my rows, my message type is split into columns, whereas it was just one column. We've split that out, we've pivoted the message type basically, and then we've got the values as sum. And then here, I can then filter on a particular, the row itself. So that's pretty much how we deal with pivot tables. So use that, it's really, really cool. It's been in about a month or so, I would think. If I dismiss that and go to, we also have widget sharing. So prior to this release, widgets couldn't be shared on their own unless they were part of a shared dashboard. But we've changed this now so that you can basically, you now have the ability to share with both users and groups in isolation. So I could just basically click on the three dots and do share for this particular little widget here. And then I would get all the same share options either to users or to particular groups, or I could auto share to a group, or I could generate a share URL or a secure URL. So all the things, if you're used to sharing dashboards, exactly the same functionality is now available for a particular widget. And then I have one more thing for you, which is a really handy feature for admins, and that is the login as feature. So I'm going to navigate over to my settings, user settings, and if I go to the team function, that's how I see who is in my team. I have a couple, one is me, and then there's a viewer here, a view user, if I scroll down, there'll be a little head icon, and I can log in as that user. So basically, I am able to then log in as them. It's going to make sure that I want to log in as that user. And this is obviously only if I'm an admin. And then it's going to take me to that user's view. This user only has one widget, it doesn't have much going on. But basically, it tells me that I'm currently logged in as one of my team members. And then I can basically see, I can troubleshoot if they're having issues. I can basically see exactly what they're seeing. And also if they've created something, for example, and they forgot to share it with me explicitly, I could go in and change that setting. So this is really a handy feature that we've put in, and very well used. And again, only if you're an admin user. And then when I'm finished, basically, looking at my my colleague's dashboard, for example, then I just release that user, and it will ask me, am I sure? And then it will take me back to my own view of my own account, wherever I was at the time. So that's about it from me. Thank you for taking the time today to hear what's new with Knowi. As you may or may not know, we do release weekly, so fixes and features are being added all the time. And with that, I'd like to now hand you all back over to Kim for any Q&A.
Great, thanks, Lorraine. So we're pretty much at time, but we got a couple of questions that we'll do real quick. So one on the widget share, are you able, do the query parameters still work with the widget sharing? So if you have a query parameter set on a user, will that still invoke on the query, on the widget share?
Yes, that will still be able to be passed in.
Okay, perfect. And then we have somebody who has a very good memory here because they were recalling something about previewing joins, previewing at each join step. I don't think we went through that, but.
Oh, okay. I actually went through, I think that was last webinar, but yes, we do. I can quickly show you that basically if I pull up my old join here that I did, my Mongo MySQL thing here. So obviously this is my Mongo and I'm joining to MySQL. If you look on the left-hand side, you see this really little funky eye icon here. You can then just pretty much go in and it shows you the data of that step, which is really, really handy. Because when you've got, like me, when I have multiple joins in my queries, I like to see at each step of the way what my data looks like for that particular join criteria or for that particular query. And you also have the ability to reorganize your joins. I might want to move my MySQL to be above my Mongo, for example. I can do that by these little arrows. Hopefully that helped answer your question.
Yep, that answered the question. So, and I think you did mention this, but maybe you could reiterate on the shared, again, back to the shared widget, there is the option to embed that widget, correct?
Yes, there is. Yeah, absolutely.
And is it the standard ways through the API and iframe, or are
yeah,
okay.
Yeah, standard ways.
Perfecto. That seems to be it. So with that, I'm going to thank Lorraine for her excellent demo and thank all of you for taking the time to join us today. As I said, we will send out the recording either later today or tomorrow morning. And with that, I thank you and have a great rest of your day. Bye.